Okay, my students are starting to graph dependent and independent variables, and I thought that I would kind of do this item with them to demonstrate how they can do this. Now, we're working with linear equations, and that's obvious because we've got this straight line here. Now, I do want to stress to my students, because they get kind of confused. They see this oblique line, and they say, that's not straight, it's slanted. Well, it is straight in the fact that if I wanted to, I could put a ruler up to it, and I could hold that ruler to it, and you're not going to have any peaks and valleys. It's going to be just a straight line. Now, I'll go ahead and launch one of my math tools here, the ruler, and show what I'm talking about. So if I were to take this ruler and hold it against that line, if I can do this, you'll notice that it does not have it doesn't have any peaks and valleys. It just lines up straight with the edge of that ruler. So this is a straight line because we're dealing with a linear equation here. Okay, so I'll go ahead and get rid of our ruler. Well, maybe I'll just have to drag it outside. Let me just pull it outside. Now, let's look at what we have here. It says, use the graph to complete the table. Now, this is our table that we're going to be completing, and this is the graph that we're going to base our values here. Now, we know, we learned this very recently, that anytime you have a dependent value, it's going to be on the y-axis. And our dependent value here is going to be the delivery charge. And I'm going to go ahead and put a D here because the dependent variable, in this case the delivery charge, it is dependent on the weight in pounds of the furniture. And this is our independent variable, and it's always going to be plotted on the x-axis. And here you can see that this is the pounds, which is not labeled here, but I can put that here, furniture, weight, and then I'm just going to abbreviate LB because these are in pounds. Now, let's look at our first point. Our first point is right between 40 and 60. I know that it's going to be located at 50 on the x-axis, and on my y-axis it's located at 10. And I'm going to go ahead and plot that in here. So our furniture weight in pounds in this instance is 50. And so the delivery charge in dollars is going to be $10. And since our units of measure are listed with the headings here, I don't have to try to cram that in. Now let's look at this one. I'm going to go to this one. This one's hard to see. I do see that it falls on 80, but it's hard to tell where it falls on my y-axis. So I'm going to hold it for the last one. But here I see clearly that this is located at 100 on the x-axis and right on that line for 20 on the y-axis. So I'm going to say that 100 pounds is going to cost $20. Now let's go to this. This is on the line for 80, on the line for 80 pounds. But it's hard to tell what it is on the y-axis. So what I'm going to do is I'm going to go ahead and write my equation to describe the graph right now. Because once I do that, it becomes obvious what my y-coordinate needs to be here. If I have 50, and let's just go ahead and look at it like this. Let's say y, the y value, so why not make it the variable y, the delivery charge or whatever, then is going to equal, I'm going to say the weight 50. What do we do if y is equal to 10? What do we do to 50 to get 10? What do we do to 50 to get 10? All right, Gracie?
You divide it by 5.
You divide it by 5. So if we have 50 divided by 5, y will equal 10. Okay, let's look at it again. Let's say we've got 100, and if y is equal to 20, what do we do to 100 to get 20?
Divide it by 5.
Divide it by 5. So let's say that we know that we have let me clear that up a little bit there. We know that we have 80 for sure, and we've got this pattern, we're always dividing by 5. So what will we get if we divide 80 by 5, boys and girls?
16.
16. So even though it looks very close to 15, it's not on that line. So it is actually 16. So we can say that this value is 16. Now we'll go to B, then we'll do C and D. Name the independent and dependent variables. I have done that. Describe the relationship in terms of the variables. Well, it's a direct relationship. When the x value goes up, the y value goes up. When the x value goes down, the y value goes down. So this is a direct relationship. Now back to my equation to describe that graph. We have come to see that if we have our y value is determined by our x value divided by 5. That is the algebraic equation I would use here, because we proved it here. This y here would be 10. This y here would be 20. This y here would be 16. So we were able to prove that the formula y equals x divided by 5 is how we're going to get all of our other values. So if I had 120, if I divide it by 5, it's going to tell me my y coordinate. Now, one thing I wish I had done, I wish I'd put this 120 in this line, and here 80 and 16, but I didn't. Now let's look at D. D says if Kiko was charged $15 for his furniture delivery, did the furniture weigh more or less than 100 pounds? There's a couple ways I could do this. I could see that you have to pay $20 for 100 pounds and $15 is less than 20, so I know it's going to be less than 100 pounds. It's actually less than $16, so that and $16 is 80 pounds. Or I could simply take that 15 and times it by 5,
Get 75.
and I would get 75 pounds. So I could do it that way. But I'm going to say that the $15 amount, I'm going to say would be less than 100 pounds. Now, what I think I'm going to say for my math practice is I use this model to help me. I mean, I use this, I made a model here with my table. I filled in the information I needed to, and then I filled in my coordinates here, and I used the model to help me figure out my formula, and I used it to help me figure out if $15 charged for a furniture delivery, whether or not the weight would be less than or greater than 100 pounds. So, boys and girls, after you saw this demonstration that I did, how many of you feel pretty good about the work you've been doing? Okay, I see hands everywhere. That's wonderful. How many of you slipped up on the 80 pounds and $16 delivery charge? Okay, how many of you say it should have been 15? You thought 15. Now you got to realize that it has to be proportionate. I mean, it's not like you can go from a $50 50 pounds to $10 and all of a sudden $80 to $15. It's not proportionate. It's not going to work that way. You had to do a little bit of math there. Gracie, you have a question?
Yeah, I thought it was 15, but I did 80 divided by 5. I did 15 times 5, that's 75, so I changed the 80 to 75, but
Okay, so you said that, now 75 would be located about here, yeah, okay. But now 75 and 15 would have at least kept it consistent. Do you have a question, Logan?
I think what I've done wrong, whenever I was working it out and stuff, and I thought it was easy, but whenever you got to the middle one, I seen what I done wrong. I got a ruler and seen that they wouldn't even, I didn't know what to do, and I just said 80 and 15, and it makes a lot more sense whenever it's counting by ones after 15, 16. It makes a lot more sense, basically.
Yes, yeah, it does. All right. All right, I hope that this little demonstration's helped you.